Welcome, Kevin Curry here from Currymath.weebly.com, at Mr. Kerr on Twitter. We're going to do evaluation, aka substitution of expressions. Very basic stuff. Again, we're still in the more pre-algebra before we get to equations, which will be coming up probably next. If I guess I'll probably go in order there soon. So this is the last one in Unit 2. On my website, currymath.weebly.com, I have all my notes from when I taught in Arizona, just algebra. I also taught geometry. If you need help with either, or even up to trigonometry, maybe a little bit of pre-calculus, I can help you out. Just tweet at me, at Mr. Kerr, and I will help you out. That's what I do. So, without further delay, let's get to evaluation, aka substitution. And I say aka substitution because that's how I learned it, and that's how I like to teach it when we do systems of equations, because it's much easier. And so I am on the only notes for this section. It's pretty basic. A lot of my kids do well on this evaluation on my notes. So if you're pulling up the page, I'll give you a second there. I'm going to write out number 1. I like to set up my worksheets in 3 columns, where I'll do the first column. My students and I would go back and forth with the second column, and then they would practice on the third column. This worksheet is very long, plenty of examples, so there's only one worksheet here, front and back. It's not bad. It should take you about 15 minutes to do them all, if you do them all on your own. Number 1, I'm only doing 1, 4, 7, 10, and 13. If you have any questions, tweet at me, at Mr. Kerr. Let's do this. 2x minus 4, where? Sometimes you'll see them say when x equals 5. So, what we want to do here is say, what information did they give us? They gave us an expression. They gave us what x equals. Let's put parentheses around what x equals. 5. I'm going to take that 5 and its parentheses and make a little bull tail or a devil tail, and we're going to plug it in right where x is. If it helps, you can scratch out the x. What does that look like now if I rewrite it? Well, 2 stays where it is. We didn't do anything to that. The parentheses 5 comes in and subtracts 4. You gotta stay structured. The more structured you are, the easier algebra becomes. Something I preached. 2 times 5. Is it distributive property? No, right? This is just straight multiplication. 2 times 5 is 10. Bring down your minus 4. One step at a time. 10 minus 4. 6. Our answer is 6. Your answers for these are probably just going to be one number all by itself. Could be a fraction. I don't expect anything too difficult. Okay, that's number 1. We're going to do number 4, 7, 10, and 13. If you need time copying it or you need to re-explain, that's why there's a pause button. That's why there's a slider where you can slide it back and hear my explanation if I'm talking a little too fast. 4. So we have 3. This is a t squared minus 2. Now variables come in all letters. Where t equals negative 2. Right, so we're going to do the same. It's the same process, right? It's all about saying structured, same process, order of operations. What did they tell me? They told me t is equal to negative 2. So I'll put my parentheses around negative 2. And I will make my little bull tail. And we're going to put it right in there for t. And we're just going to cross out t. Notice the 3 stays, the little 2 stays, the negative 2 stays. My coefficient, my exponent, and my other term all stay the same. What will this look like if I rewrite it? So 3 will stay, as I said. T is gone. Bye, bye, bye. Exponent stays where it is. And negative 2. Right? So now there's a little bit more of a problem with, in terms of simplifying, we need to use PEMDAS. Over here, we'll write PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction. A lot of people say G grouping symbols. It doesn't matter. It doesn't really matter, to be honest with you. Parentheses are grouping symbols. No need to make a fuss out of it. Parentheses, I see them. Do I see an exponent? Yes, I do. That exponent means we're going to multiply this by itself this many times, or expand it wrote this twice. Multiplication. 3 times a negative 2, negative 6. Notice I'm only solving one thing at a time here. I like to be structured. I like to take my time. A negative times a negative is a positive. 6 times 2 is 12. And 12 minus 2, 10. Our answer is 10. Right, take your time. Make sure you understand the exponents, right? This shouldn't be a positive 2. It's a negative 2 twice. Let's do number 7. Fractions. We're starting with these fractions, and I like these. I had to try to make these difficult. I wrote all these. I wrote every single one of these notes. We did not have a textbook. Everything was quizzes and tests. It was wonderful. That was a little bit of sarcasm there. It was very difficult curriculum. 2c plus 4. All this is over 4. And I'm saying c equals negative 6. Okay, there's so many ways you could do these types of problems. Again, I taught a lot of remedial students, students that worked hard, so I knew that if I gave them more structure, their hard work would pay off. So this is how I would solve them. I would say this line is a divider, right? There's really 2 kinds of problems here. We have 2c plus 4. There's one of our problems, dotted line, and we have 4. Right? You see how I split that. Then it looks just like problems we just did, right? It looks like 1s and 4s. So let's go ahead and parenthesize what they tell us and plug in with our little bull tail. And if it helps, you can cross that off. What does this problem now look like? Well, it looks like 2 times a negative 6 plus 4. Positive times a negative, negative 12 plus 4. Negative 8. Now, that's not my final answer. If you remember, I took this apart. Right? I take it apart, I have to put it back together. This was on top, let's put it back on top. Off to the side, we have negative 8 over 4. You can see that I took the top apart, solved it, and I'm going to put it back where it is. Negative 8 over 4. Can I simplify this? Yeah, 8 over 4. Factors of 8, 4 times 2. Factors of 4, let's say you said 2 times 2. Great, try to reduce this again. 2 times 2 again. It's going to be 2 over 1. Negative 2. Right. Work on reducing those fractions. That might not have been the best example, but have you seen any of my other videos? Pretty easy way for remedial students to simplify fractions, so they don't have to be afraid. Let's do number 10. Numero 10. 10 and 13, and that'll do it for this video. Again, these videos are supposed to be short, supposed to be a supplement. If you need tutoring, you need a little crash course, maybe you see a problem. If you have any problems, you can tweet at me, at Mr. Kurt, and I will help you through your problems. I'll try not to do any problems. I know that teachers assign the work to the students, not the tutors, not the parents. Chances are I'll be able to come up with another similar problem where we can talk about it. So here we go, right? Similar looking problem. Let's solve it the same way. Let's draw a line down the middle, and let's take this expression apart. On one side, we have negative 5n plus 6. On the other side, we have 4. Solve it just like we did the earlier ones with telling, hey, what does n actually equal? Well, it equals negative 6. We're going to plug this in where n is, and we're going to rewrite that. So let's rewrite it. If it helps, you could cross it off. And what belongs in that space? Well, negative 5 will stay the same. Negative 6 will go in, and put a plus 6 there. Negative times a negative is a positive 30, plus 6, which is a positive 36. Final answer? No. And I tell my students, anytime I ask if that's the final answer, 90% of the time it's not. We took this apart, let's put it back together. What goes on top? 36. Goes on bottom, 4. If you have a calculator, you can go ahead and 36 divided by 4. You might know it, you know your multiplication chart. If not, you can do factors. 9 times 4 over 4 times 1. answer will be a positive 9. Right, simple, simple, simple. Stay structured. Check your signs, right? Discipline, I call that discipline. Checking your signs is discipline. Last one, number 13. You might be wondering, why are these problems so easy? Some of you. Why is there not much variation? Well, I don't know. The quizzes were very specific. I had to make an excuse of. And 18. So we have 2q times quantity q minus 5 over 18, and this q, that q equals 6. Fraction problem, split it up. 2q, q minus 5 on one side, 18 on the other side. Let's go ahead and make our bool tail. Q is equal to 6. Why is this problem special? Why is it different? Why is it last? Right? I try to keep my harder problems for last. Why is this one last? There's 2 Q's, right? Just do it twice. Make 2. Q has to be substituted each time you see a Q. There could be 50 Q's. You have to substitute them each time. Let's plug them in. What am I left with there? 2. Stays the same. Parentheses 6. Inside parentheses, 6 minus 5. Alright, there's a lot of ways. Parentheses, I don't actually need this parentheses in here. We can multiply these and then distribute. We can simplify here. Let's actually multiply these first. We'll make this a little bit more difficult since this is just tutorial. 12. Let's bring 6 minus 5 down. Okay, let's distribute our 12. Remember, when you distribute, you have to go to each number on the inside, each term on the inside. 12 times 6, 72. 12 times 5 is 60. 72 minus 60 is 12. No, it's not my final answer. I'm not even going to ask it. We took it apart, right? This was originally on top. This was on bottom. Let's put them back together. 12 will go on top. 18 will go on the bottom. Can I reduce that? Absolutely. It's not going to be a whole number. 6 times 2. 6 times 3. Well, it'll cancel out my 6's. Final answer is 2 over 3. 2/3. So that does it for evaluation, aka substitution. That does it for Unit 2. This is Kevin Curry. Go to my website, currymath.weebly.com, and check out all my worksheets. If you're a teacher, it's a good resource. If you're a student, good practice, a lot of practice examples. I taught a 2-hour class, so I had to come up with a lot of examples. If you need help, tweet me at MRCURR. Have a great day.